guys, lesson check 9-2. Let's do it. It says, which is a plan to show that M and M are perpendicular? So in our notes today, we said the slope of line M, if it was 3/2, and the slope of line M, if it was negative 2/3, right? Opposite reciprocal. Then if we multiplied those two, the slope of line M and the slope of line N, we should get, when we have opposite reciprocals, we should get the product to be -1. So which one is that? It says they're not equal. No, we want them perpendicular. That'd be for parallel. Show that the slope of M is equal to negative. No, it's not the negative. Show that the slope of M is equal to the slope of M is equal to -1. Divide by the slope of N. Yeah, this would be true. If we took the slope of M, let's play this out again. This is actually slightly different than what they asked us in our notes today. If we took the slope of M, 3/2, and we equaled it to -1, divided by the slope of N, then this would equal, that would be equal. So see how they flipped this upside down? That's what that symbol would do, to flip it upside down. So you make it negative and you flip it upside down. When you divide a number, you flip it upside down. Yep, so I'm going to pick C. Next one, it says if the parallelogram is a rhombus, its diagonals are perpendicular. So let's use coordinate geometry to prove this. So which of the following depicts an arbitrary parallelogram in the plane? Okay, so here, an arbitrary parallelogram would have a certain width, A. That looks good. So an certain width, A. I like that. Here, we would probably want to keep it on it. So I don't like C. Okay, and this one, certain width, A. Okay, we like that. Now here, to get to the next point, we know that this distance A would be this same distance. Yeah, so I really like either A or B, because whatever I'm at here, like here it says I'm at B in the X direction, and then I want to add A. That's exactly what I want to do, so that I preserve that width. Yeah, so now I've eliminated D, so now I'm down to A and B. Now what else? Well, if I think about this, this coordinate has to be a different number B and a third number C, because the height of my parallelogram doesn't have to match my width. So I'm going to pick A. So what is wrong with B? This is saying I went over a width of A. This is going, I went over a width of B and went up A. I can go up, for a parallelogram, I can go up any height. I don't have to go up this same height. So A is definitely my answer. All right, 3, show that all the statements, so we have to pick all, that would show that it's a parallelogram. Okay, so parallelogram, D, E, F, G. If they show that these are equal, so again, think about grabbing 2 pens and then making those 2 lines parallel. Would that force it to be a parallelogram? And I think I can't not draw a parallelogram, so I'm going to pick A. Now if I took DE and I made DE perpendicular to FG, so somehow I can't really do that, so definitely not going to pick that, right? For a parallelogram, F and G have to be over here on the right. For C, it's essentially saying the same thing. Instead of saying they're congruent, they're equal in measurement. So if they're equal in measurement, so 5 centimeters, 5 centimeters, and then you force them to be parallel, then yeah, you're going to get a parallelogram no matter what. So I'm going to pick that one. This one says, let's say, once again, you make them the same distance, same length, 5 and 5, but we make this one perpendicular, that's not going to be a parallelogram, right? Last one, let's say you took DE and made that equal to FG, but you made angle DEF 90. So I'm going to have to redraw that. Make angle DEF 90. And I forced this length, DE, to be equal to that length. That's going to give me a parallelogram. Remember on my family tree, a rectangle, it's giving me a rectangle, and a rectangle is a parallelogram. All right, 4. Select all of the statements that would show that the diagonals are perpendicular. Okay, so if I have H and J, so when are diagonals perpendicular? That happens when I think you have a square, a rhombus really. So let's kind of try to draw a rhombus here. H, J, K, L. So if HJ is perpendicular to KL, well, wait a minute. No, those need to be across from, so I'm not going to pick that. If HK is perpendicular to JL, then yeah, those are the diagonals. So to pick diagonals, you're going across, right? You're not going to the point next to, you're going to the point across. Now, what if we said that the slope of this line, HK, we don't want HJ, that won't work, but if we said the slope of HK, this slope is equal to negative and then flip upside down of the other one, yeah, we like that, so we're going to pick that. And then what if we just made HJ, this line, parallel to KL? Would that be enough? Well, essentially, that's just, in any old parallelogram, those are not necessarily going to be perpendicular. So in a regular parallelogram, the diagonals are not necessarily perpendicular. Notice how these two lines don't meet at a 90. So we're going to say no. All right, last one. Complete this sentence. So if we went to draw a square at 0, 0, so that's A, right? And then we went over a certain distance. So I think this is just like our nodes. So 0, this would be, our next coordinate would be, I got to do a square, so I got to go up the same, right? I went up a certain distance, 0A, right? And then I went over a certain distance, AA. And lastly, this distance would be A0. Yeah. All right, now if I wanted to draw another one, I could do a different distance. So let's say I wanted to go a little smaller. This one would be B0, right? This one would be 0B. And then this one would be BB, right? And that's what that's saying there. So that would be a 0. Explain how these two squares could represent two squares to show that they would map on top of each other. So I would need to take the first square and shrink it to make it map on top of the second square. So that would be called a dilation. Looking through your multiple choice, you should be able to find one that matches these. Nice work, guys. See you next time.